Okay, kids, I'm in the dark. No, I mean like literally in the dark. Figuratively, I'm always in the dark, but I'm in the dark here today. I'm going to do a little lens. Let's talk about lenses today. We just finished up on mirrors. Okay, we all know that mirrors have doinking going on, and we drew some pictures with those and showed the doinking. And I had my BFM, remember my BFM, my big freaking mirror, and we were able to get an image onto it, but I had, of course, hold a piece of paper. I held the piece of paper out in front of the mirror and got it reflecting on the piece of paper. Today, I'm going to show you that we can do the same thing with lenses. We can get an image to form on a piece of paper with a lens. Now, of course, there's no doinking going on with lenses. Okay, there is reflection with mirrors, but there is refraction with lenses, so light goes right through. In fact, look at this. I have a BFL, not just a BFL, a BFL, a big freaking lens. Yeah, this was actually the one that was in my eye, in my right eye. I took it out, and here it is. I saved it so I can use it for physics demonstrations. This is actually called a planar convex lens. It has a rounded side and a flat side to it, as opposed to, so it's a planar convex, as opposed to a double convex. This would be a double convex lens, and it's both sides bubble out, so it's a double convex. And I also have a diverging lens. It's a concave lens, a double concave. It's thicker on the edges and thin in the middle. Thin here, thick here. And if you wear eyeglasses, this is what you're going to have if you're nearsighted in front of your eye to correct your vision if you're nearsighted. I do a whole thing on eye optics, so yeah, you'll hear about that, I'm sure. Now, what I wanted to do here to start out is to show you that with a lens, okay, take a piece of paper and we can get an image on a piece of paper. And remember, that's how you know you have a real image. Real images can be formed on a piece of paper. That's how you know you have a real image. If it's formed not on the piece of paper, like in the mirror, or you can also get virtual images with lenses. Okay, it appears that the object is there through the lens, but it's not. That's virtual. Now we can get those as well. But I wanted to show you. We'll take the BFL, the big freaking lens, and I'm going to show you that. Now you're seeing a reflection of the window in the back out of here. We can get a reflection as well. Like you can get reflections from windows, you know that. Light goes through windows, but you still get a reflection. But we also get an image projected onto a piece of paper. So this is going to be tricky here to try to show you, because it's got to be right in back of the mirror. So right there, oh, I got a nice crystal clear. That is a nice, let's see how am I going to show you this here. Oh, there it is. Kind of got it. See? See it back here on this? Yeah, you can see it. It's a little blurry because I had to tilt the lens to get it on the piece of paper, but there's an image on this piece of paper. And that is a real image. So that was my planar convex. We can get the same image of the window with a double convex. Now, double convex is really focusing the light. This is a converging lens. We're really focusing the light. So double convex means I have to get that paper pretty close. So here's where I had the paper with the planar convex. Now, to get an image here, I got to move this thing right up there. I got to get right close to it. Like that is a nice image of it. Oh, you're not seeing it. Okay, there we go. We kind of see it now. It's hard to get this done and show you, but you have to move this double convex very close. I got an image on the piece of paper and back there. Now, if I use the diverging lens, nothing. I can do this all day, and you will not get an image on the piece of paper because it's diverging the light. That's the concave lens, and a concave lens diverges light, and you can't get an image out of that. You can't get a real image with this. So you can only get a virtual image, like now. Oh, there we are. Oh, look at me. Look, there's two me's. There's my big head me and the small head me. And that is an image being formed, but you can't get that on a piece of paper. It is a virtual image with a lens. Okay, so let's go take a look at these. We'll draw these out. Turn the lights back on. Ooh, bright light. It's like Gremlins. Have you ever seen that movie, Gremlins? Gremlins don't like bright light. They don't like water, and do not feed them after midnight, okay? Some of you know what I'm talking about. Gremlins. Watch it. It's a good movie. So when we have lenses, okay, I showed you one of these. I showed you one of those. That was my BFL. That was the big freaking lens, the smaller one. And I showed you one that was like this, my diverging lens. So there's three different lenses here. Well, basically what we're going to do is we're going to stick with either concave or convex lenses. But both of these will function to converge light. So these are convex lenses. As long as you have one side that's convex, you also get what's called converging. So these words go hand in hand. Converging, convex. And a converging or convex lens is also known as a positive lens. Are you sure? I'm like a proton. I am positive. I'm a proton. I'm positive. It's funny. It's funny. I'm positive. Proton. So these are three different words used to describe that kind of a lens. Like with mirrors, we have three different words to describe a mirror. A curved mirror can be concave. It could be positive or negative. And it could be converging or diverging. We use the same terminology for lenses. So here I have a lens which is diverging, but it's concave. So let's write that down. Concave, bubbles in. And this is the opposite. The opposite of each one of these is diverging. So diverging. And then this would be a negative lens. And that positive and negative is going to be important to remember when we start doing the lens math. We need to remember that. So these are the three different kinds of lenses. Now this one here and this one here both will converge the light onto a point, which is why we can get an image out of it. This one does it faster. It does it, so I had to put the piece of paper right close to this one because we've got double convergence going on here. This one I had to put it farther away. It only had a single convergence. So but they still both will converge the light to a point, and we can get real images out of these. We can also get a virtual image as well out of these. This one here is used as a magnifying glass. Like if you're going to use a magnifying glass, you use one of these, and it magnifies things. I mean, when you have something up close to it, whoa, look how big my finger is. Whoa, dude! Little finger, big finger, little finger, big finger. It's a magnifying glass. So there we go. Now, the magnifying glass, this is actually a virtual image. My finger is a virtual image. It appears to be really close to the lens, but it's not. It's farther back. And we'll draw that one out in the lens drawing portion a little bit later. And you will see how come you get that magnified image out of that. All right, so here are our different kinds of lenses. We will just do some terminology here showing you that we now have lenses to work with instead of mirrors, but the optics still continue with the same words. We're using the same words here, and we will see when we make images, we will use the same word bank that we used before, like upright, reduced, enlarged, virtual, real. All those words still don't go away. Okay, so just kind of a general introduction to lenses, and next I'll make one on lens el mazo. All right, see you soon, kids.